stable ring. Okay, so let me clear this. Are there any questions on this rearrangement before I clear this and do one last example? Okay. So what about ring expansions? So these alkanide shifts and alkanide shifts can also lead to ring expansions. So for instance, if we start with this, we can actually get this alkene. Okay, so we would call this starting material, this would be a 2-butanol. Sorry, that's not a 2-butanol. We would have to name this a little bit differently. So this is a cyclopropane with a methyl attached and then with a hydroxyethyl group. And that's a level of alcohol nomenclature that we have not really worried about yet. So we will not worry about it right now. So what's happening? As usual, we need to protonate this alcohol. And that's going to then create that as a better leaving group, right? And then we can dissociate the water as a leaving group to form a carbocation. And now here's the tricky part. We could, in theory, do a methanide shift, and that would give us a tertiary carbocation. And then we could do a proton abstraction to make an alkene. However, right, we've next to the carbocation, we've got 1, 2, 3 different bonds that would be in hyperconjugation with that carbocation. So if I shift the methanide, I don't gain anything. I mean, I'm gaining a tertiary carbocation, but it won't explain my product. Whereas if I take a bond from the ring, so take this bond instead of the bond to the methyl group and shift that, now not only do I form a tertiary carbocation, but I also get rid of some strain energy in the ring. Okay, so this is a little bit tricky to draw. Here's where my carbocation is. So let me color code some bonds here to make it a little bit easier to track. So this carbon-carbon bond right here is this. And this carbon right here is this. Okay, so we're shifting the red electrons over to form this bond. And then once we've done that, okay, by the way, I did not draw this arrow reversible. Okay, once we expand to our 6-membered ring, this is not going backwards. And then finally, water can abstract a proton to form, as the major product, this alkene. And this is going to be the major product versus abstracting a proton from here or one from here, right? Because of Zaitsev's rule. That's going to be our thermodynamically most stable product, the most substituted alkene. Okay, so again, we get ring expansion rather than let's say methyl shift, because we relieve ring strain. Okay, these are complicated. They're awkward to really see what's happening in this process, but with a little bit of practice, you'll get it.